This is lesson 3, representing proportional relationships. This is the second part of activity 2. So activity 2 is representations of proportional relationships. There are 4 representations that we talk about. And this is part 2. This is another example of those 4 representations. So one of the representations, one way to show or represent a proportional relationship is through its description. So the Origami Club is doing a car wash fundraiser to raise money for a trip. They charge the same price for every car. That means it's a proportional relationship. If they don't, there's nothing about any fee up front. So if they don't wash any cars, they don't make any money. So this is a proportional relationship that goes through 0, 0. After 11 cars, they raised a total of $93.50. This is the beginning of a table. One property is the number of cars. The other property is the amount of money they make from washing those cars. So those are the 2 properties that are going to be compared. If they wash 23 cars, they make $195.50. So again, this is the beginning of a table, and here's that table right there. So number of cars is 11 cars, $93.50. 23 cars, $195.50. So usually we put the x values, the values along the x-axis on the left side and the values along the y-axis on the right side, because the value for x is usually the number that you know. You are given, in this case, the number of cars, and you calculate how much money that you make off of those 11 cars or 23 cars, whatever. So this is usually the x value, and this is usually the y value. So the y value you can think of as the answer to the problem. How much money did we make after washing 23 cars? Oh, we made $195.50. And you can switch them around. You can call this the x values and this the y values, depending on the situation. But most of the time, the x values are going to be on the left, the y values are going to be on the right. So what is x and what is y? Well, we just said that. So the number of cars are going to be along the x-axis. The amount of money raised is going to be along the y-axis. This is the beginnings also. From the description, you can start to see the table. You can start to see the y divided by x, the constant of proportionality. So usually when you know the number of cars, you calculate the amount of money. So number of cars is along the x-axis. The amount of money is along the y-axis. So this is the equation that we've worked on for quite some time now. So the amount in the vertical direction is the y value, and the amount in the horizontal direction is the x value, and that ratio is the slope. That is how much. So if you plot the lines, the points based on this ratio, you're going to get a line. You're going to form one of those slope triangles, and the steepness of that line depends on this ratio right here. So this is what we went through a while ago. So the slope is the ratio of the number of units in the vertical direction compared to the number of units in the horizontal direction. And from this you can build a table. Now their choice of 11 cars and 23 cars is an interesting choice, because if you double the number of cars from 11, you go up to 22. So I'm going to slide this row down here, and in this row I'm going to put 22 cars. Well, how much do you make from 22 cars? Well, you make double the amount. So that's going to be 2 times $93.50. So if you double the number of cars, you make double the amount of money. That is a proportional relationship. So if you double one property, you double the other property. Now, the reason it's an interesting choice is this is one more car. So how much more money do you make? Well, you make $8.50 more. That is the unit rate. How much do you make for one car? You make $8.50. So without doing any division, you can figure out what the unit rate is. Now you can check yourself. If you divide $93.50 by 11, you should get, and you will get, $8.50. If you divide 187 by 22, $8.50. Divide 195 by 50 and 50 cents by 23, $8.50. That is how much you make per car. And when you do the division in each case, it always tells you how much you make per one car in this case. So one car, one unit, is $8.50. Now, if they want to make, how many cars do you have to wash to make $200? You just add another $8.50 to this $195.50. And this actually would push the total up to $204. So here's the constant of proportionality, which is the same as the slope, which is the same as how we're writing the equation. And the reason you can just use y and x is because it's a proportional relationship. It goes through 0. That's why there is a constant of proportionality. And it's $8.50. So what that is saying to you is that the vertical direction, in this case $93.50, is 8.5 times the horizontal direction, the horizontal number of horizontal units, number of units along the horizontal axis or the x-axis. So 8.5 times 99 times 11, would be $93.50. So the vertical number of units along the y-axis is 8.5 times the number of units along the horizontal axis. And that's what this says right here. The value in the the value in the y direction is 8.5 times the value in the x direction. So the value for y is a lot, that unit number is a lot larger. It's 8.5 times whatever that unit number is for the x value, for the number of cars, because you make $8.50 for every car. Increase in one car, increase in $8.50. This is a lot. This is why I'm going through it slowly, and I'm doing one video for each of these problems, because it takes a lot to think through this. So what does the graph look like? If you look at the table, how high does this table go? Well, it goes along the y-axis, it goes up to $195.50. Well, that's pretty close to 200. So let's just call that 200 along the y-axis. Along the x-axis, it goes to 23. But if we're going to bump this up to 200, we should bump this up to 23, 24. Actually, 24 will get you just over 200. So along the x-axis, you probably should make that 24. So you count the number of units along the y-axis, and you find out that there's 10 of these lines, and you want to go up to $200. So 200 divided by 10 means that each one of these lines is $20. So this is $20, $40, $60, $80, $100, $20, $40, $60, $80, $200. So that's the scale. So what value are you going to put for each of these marks? I'm going to put $20. So this becomes $100. This becomes $200. So this is the amount of money made. And these are the number of cars along this axis. So if you count out this way, you're going to get out to 25 out here. So you can make each one of these marks just one car. This is 5, 10, 15, 20, 25. And so remember, you have to put the label along each axis. So this is the number of cars. That's one property. What's the other property you're measuring is the dollars made for each of these cars. So you have to put money along this axis. So you'd probably write money in dollars to make this proper. And again, this is the scale. This is the scale. So what are you going to call each one of these lines? That's called the scale. And then the label. All right, so remember, it goes through the origin. So this is a point on the line. It goes through 0, 0. If you haven't washed any cars, you haven't made any money. And so if you want to look at the unit rate, so the unit rate is how much money do you make for washing a single car? So to figure out the unit rate, you go to the x-axis and you go to 1. In this case, one car makes you $8.50. So that is the unit rate. How much money do I make for each car that I wash? And the answer to that is $8.50. That's called the unit because it's the unit, one car. It's the unit rate. All right, so one car is $8.50. 11 cars is $93.50. You get that from the table. You can also just multiply 11 by $8.50, and you get $93.50. And if you double the number of cars from 11 to 22, proportional relationship tells you you're going to double the amount of money you make from $93.50 to $187. So that's going to be about right here. So you go up to 22 cars, you go up to $180, $187. Halfway is $190. So this is pretty close to halfway. And you just have to guess at this point. You know that halfway is 190, you know you're at 187, so you're pretty close to halfway. And if you add one more car, 23 cars, that's going to get you out to $195.50. So this gap here from here to here is that $8.50. Now, if you want to ask, how many cars do I have to wash to get to $200? You need one more car. So let's look at this first. Here's the line. You draw this line, and that tells you all the information, the relationship between the dollars and the number of cars. So anywhere along this line, you can look at the number of cars, 5, 6, 7 cars. You go up to here. Looks like 7 cars makes you $20, $40, $60. And that's probably correct. 7 times $8.50 is $60. So that's how that's why a graph is so useful, because you don't have to do the calculations anymore. You can just look at it and tell what's going on. So this is the equation for that graph. So y is equal to, and this is the constant of proportionality. It's also the slope. It is also the unit rate. So all of those things get folded up into one number. So the amount of money you make is $8.50 times the number of cars that you wash. And so you look along, the x value is the number of units along the x-axis, and the y value is the number of units along the y-axis in this equation, because it goes through the origin. All right, one more car up. Actually, money is equal to $8.50 times the number of cars. And if you need to get to $200, so maybe the fundraiser is you have to make at least $200. So how many cars do you have to wash? You would go out one more car from 23 cars to 24 cars. You go up to this line, and this gets you over 200. So what is it? What is the value? Well, it's $8.50 plus $195.50, and that adds to $204. This right here, this line right here, if I went across, would be $204. All right, so the 4 representations. One representation is the table. So we did a lot with the table. Another representation is the equation. So the equation can come from the table. The equation can also come from the graph. That is the 3rd representation. So it's a little bit easier in this case to figure out the equation from the table, because it's the y divided by x is the constant of proportionality. So y is equal to y divided by x times x. Y equals k. It's another value that goes here, another letter. There's a lot of things going on with the number that's placed right here. Constant of proportionality, slope, unit rate, and k. Y equals kx. And finally, the 4th representation. So you have the table, the graph, the equation, and finally, what's the story behind the problem? Most of the time, you're going to be given this. Then you use this information to start to build a table. So 11 cars, $93.50, and so on. Then you use that information to create the graph. And either from the table or from the graph, you can get to the equation, because this right here is one form of that equation. and then you can write it as y equals kx. All right, that's part 2 of activity 2 for lesson 3.